Hi friends, welcome to NIKRA'S Expert Learning. In the previous videos, we discussed what is bearing, meridian and what is the compass and all the definitions and types of meridians and bearings. So if you haven't watched those videos, please go and check it out in my channel as that is a prerequisite to watch this video. So in today's video, we are going to see what is a whole circle bearing, what is a reduced bearing and how to convert a whole circle bearing to reduced bearing and reduced bearing to whole circle bearing. So coming to the first part, let us see what is a whole circle bearing. The whole circle bearing is also known as azimuthal bearing system. Okay, this system is called as azimuthal bearing system. In this, whenever we are having survey lines, see the SL, SL2, SL3, SL4, all these four are the survey lines and these are the standard directions we have. Whenever we are taking any survey line in this azimuthal bearing system, we are respecting it from this north pole. Okay, we are taking the north pole as reference. So here the bearing of the first survey line is theta 1, the second would be theta 2, third is theta 3, for fourth it is theta 4. See, all these thetas are taken from the north pole itself. No intermediate one is there. From the north pole itself it is theta 1, theta 2, theta 3, theta 4. Okay? So simply we have this bearing system. In this the backward bearing is 4 bearing plus or minus 180 degrees. See, whenever the forebearing is less than 180 degrees, we use positive sign, but whenever the forebearing is more than 180 degrees, we go for negative sign. Okay, this is the azimuthal bearing system. In this we have only one thing, 0 to 360 degrees. The whole thing is taken as one system. That is the whole circle bearing. Next we have this reduced bearing, also called as quadrant bearing. Here we are dividing the entire system into 4 quadrants. That is why we are saying quadrant bearing. Okay, here this is the survey line. Okay, we are seeing the bearings with respect to this nearest to north and south poles. In that we are just taking only the north pole as reference one, but here we are having the nearest north and south poles. I will tell you how. See, in the first survey line, this is the first survey line. This is in the first quadrant. Okay, first, second, third and fourth quadrants. So the first survey line is simply the north pole angle, whatever the angle from the north pole. Okay, it is in the northeast direction. The first quadrant we are having in the north, between the north and east direction. Okay, in the second quadrant we have east and south. So we'll write south and east. See, remember, however, it is in between this, we will be writing north and south first. Okay, so the first quadrant is northeast and second quadrant is southeast. Third quadrant is southwest, whereas the fourth one is north and west. Okay, so whatever the theta is there, you will be writing the angles over here. From north, it is with an angle theta 1 towards east. From south, the second quadrant, from south it is with an angle theta 2 towards east direction. From in the third quadrant, from south it is with an angle theta 3 towards the west direction. And again in the fourth, from north with an angle theta 4, it is towards some west direction. Okay, here again the forebearing and back bearing will be changing. Here forebearing and back bearing is same in magnitude, but here we are just changing in the direction. Okay, whatever the forebearing and back bearing is there, you will be having same values, but only the sign would be changing, the direction would be changing. So first let us see how to convert the whole circle bearing to the reduced bearing. Okay, coming to the first one, we will be seeing 4 quadrants each. Okay, first one, whenever it is between theta is between 0 and 90 degrees. See here, we are having some theta value. Here this is the reduced bearing and whole circle bearing. Whenever the theta value is in the first quadrant, the reduced bearing is equals to whole circle bearing and whole circle bearing is equals to reduced bearing. Okay, we'll just simply keep that value, but we will be writing north and theta. So whatever the whole circle bearing is there, we will simply notify it in this notation. Okay, in northeast. Coming to the second quadrant, here we are having this survey line. Okay, this is the second survey line. So here this is the reduced bearing from south pole, the nearest one, and in whole circle bearing we will be taking only this north pole as the reference one. So whenever we are converting the whole circle bearing into reduced bearing, we have to subtract it from 180. Okay, whatever the total 180 degrees is there, if we are reducing this reduced bearing from that, you will be getting the whole circle bearing. Okay, but to get the reduced bearing, we have to subtract the 180 minus whole circle bearing. The whole term is reduced to get this reduced bearing value. Okay, so in first quadrant both are same. In second quadrant you just have to remove that value from 180 degrees. To get reduced bearing, we will be subtracting the whole circle bearing. To get the whole circle bearing, we will be subtracting the reduced bearing. Okay, see here we have this part as the reduced bearing and this whole thing as whole circle bearing. Okay, let us think we got the value of whole circle bearing and now we have to calculate this reduced bearing. So we'll simply remove this whole circle bearing minus 180 degrees. That is, we'll simply remove this 180 degrees. You will be getting this value, right? And next, we know the reduced bearing. We have to calculate the whole circle bearing. Simply add 180 plus reduced bearing. So simply add these two terms, the 180 degrees and this reduced bearing. You will be getting the whole circle bearing. Okay, this thing is the whole circle bearing and only 180 is from north and south. Okay, only this one is 180 degrees. Okay, you just have to add 180 degrees to get the whole circle bearing and subtract the 180 degrees from whole circle bearing to get this reduced bearing. Next, if we have some survey line in the fourth quadrant, here the reduced bearing is equals to, see, this is the reduced bearing. We know the whole angle is 360 degrees. If we reduce the whole circle bearing from this whole 360 degrees, you will be getting this remainder. Okay, that would be the reduced bearing. But in case you want the whole circle bearing, simply subtract this reduced bearing. You will be getting the whole circle bearing. Okay, now let us just solve some examples. See, first one, 40 degrees and 30 minutes. I told you in the first quadrant the reduced bearing is equals to whole circle bearing. So that would be same, north 40 degrees 30 minutes east. Okay, coming to the second one, 180 degrees 15 minutes, 120 degrees 15 minutes. So 120 degree 15 minutes is in the second quadrant. Here if we want the reduced bearing, you have to just subtract this whole circle bearing from 180. So that is 180 minus whatever the whole circle bearing we have given, you are just subtracting that. So that would be again in the southeast direction. Okay, coming to the third one, 178 degrees 10 minutes. So here we are given the whole circle bearings, we are converting into reduced bearings. Okay, so 180 degrees, 178 degrees, we are just subtracting it from 180 as we already know the formula. Or we can simply say it by seeing the diagram. Next, we have 240 degrees 48 minutes. That would be coming again in the third quadrant. Third quadrant means whenever we need reduced bearing, that should be whole circle bearing minus 180. See, this is the whole circle bearing from here to this position. In this we just have to subtract this part, the 180 degrees part. So you will be getting this reduced bearing. Okay, that would be in southwest direction. Southwest, whatever the angle you have got, you have to write here. And the fifth one is 299 degrees 10 minutes. So that is in the fourth quadrant. That is, this is the whole circle bearing. You just need this reduced bearing. So in the whole 360, if you subtract this value, you would be getting the remainder, the reduced bearing value. Okay, that would be in the direction of north and west. Okay, you just have to write the directions also. Similarly, taking also the other terms which are in the fourth quadrant, you just have to subtract the 360 degrees minus that value. Okay, just subtract the given whole circle bearing from 360 degrees. You would be getting the reduced bearings. Next, let us see how we have to convert the reduced bearing to whole circle bearing. The north 10 degrees 10 minutes east. See, I told you whenever it is in the first quadrant, the whole circle bearing and reduced bearing both are same. So you just have to write that value. And in this south 43 degrees 13 minutes east. See, southeast, that is, it is in the second quadrant. So this is south, this is east. It is in this quadrant. Okay, so that angle is 43 degrees 13 minutes. 43 degrees 13 minutes. So here, to get this whole circle bearing, what we have to do? We have to subtract this value from 180. See, this is the whole 180 value. If we subtract this value, we'll be getting this value. So we just did that. Okay. Even this one is same. Even for the third one, that is in the southwest direction. Sorry, this is in southwest direction. That is here. So here we are having an angle like south, west. This is 88 degrees, 12 minutes. So if this is the reduced bearing, to get this whole circle bearing, we have to add this 180. Whatever this reduced bearing is there, to this we have to add this 180 degrees to get this whole circle bearing. Okay. Next we have this northwest one. Northwest is in this direction, and here this is the angle. This is the reduced bearing. So this is the whole circle bearing. If we subtract this given reduced bearing from 360 degrees, whatever the value we get, that would be the whole circle bearing. Okay. That is it for this video, guys. If you like this video, please like, share and comment to the channel, and don't forget to subscribe to my channel. Your subscription would greatly help me. I appreciate you watching this video, guys. Thank you.